So here we are exploring parallel lines. And we say that lines in the same plane that never intersect are called parallel. And I want to review two common examples of parallel lines with you. And the first is vertical lines. So we can say that two or more vertical lines are parallel. So for example, two parallel lines might include x equals 1 and x equals 2. Now, graphically, we know that vertical lines look as follows. So we could say this is x equals 1, and here is x equals 2. And we can see that these lines run next to each other, increasing and decreasing infinitely in both directions without ever crossing. Now, what happens if we're not working with two vertical lines? So we say that two non-vertical lines with slopes m sub 1 and m sub 2 are called parallel lines if those two non-vertical lines have the same slope and different y-intercepts. We can summarize this by saying m sub 1 equals m sub 2. So let's go ahead and think about an example of two parallel lines graphically. So here we're given two distinct lines that have the same slope and different y-intercepts. So for our first line, we have a y-intercept at 2, or in its ordered pair form, we can write this as 0, 2. And coming over to our graph, here is our y-intercept. Now, let's go ahead and use the slope of this line, 1/2, to find another point on this line. So keep in mind, we know the slope is defined as the rise over run, or the change in the y values by the change in the x values. And our slope here for both lines is a rise of 1 unit and a run of 2 units. So from the y-intercept, we are going to rise up 1 unit and run to the right 2, which produces a second point on this graph, positive 2, 3. And to see the graph of this line, we simply need to connect those 2 points with a smooth curve. So let's go ahead now and think about the second line in a similar manner. So here, again, we have the same slope, but in this case, our y-intercept is -1. Or in its ordered pair form, we would write this as 0, -1. So on our graph, here is our y-intercept. And again, let's go ahead and use the slope to find another point on this line. We're using the same slope here, so we know we're going to rise 1 unit up and run 2 units to the right. So from this y-intercept, we rise up 1 unit and we go over to the right 2, producing a second point on this line at 2, 0. And connecting these 2 points with a straight line, we have the corresponding graph. So notice, taking a moment to observe our graphs here, we can see that these 2 lines are extending infinitely in both directions, but they're never going to cross. And that's because we have the same slope. These lines are parallel.